So I come to you today from the Lighthouse International here in New York, and our mission is to help those people for whom it's too late to have cures. And we take our mission to try to evaluate those devices and methodologies that propose to help people who are blind, who have low vision, restore some function to their lives. So this title is more of a hope than it is an actual fact. I'll start the slideshow. So we're currently evaluating two methods to restore visual function. So I didn't say vision. You have to remember that these things are restoring visual function, and it's a subtle distinction, but I think at the end of the talk you'll understand what I mean. And there are currently two methods to do this. One is to go back into the eye and try to replace those elements that are lost during disease. So you use what's left in the eye, and you use that mechanism to get signals back to the brain, so the brain perceives those as coming from your visual world. In many cases, like in RP, which is one of the prime candidates for retinal chip implants, the photoreceptors at the back of the eye are lost, but it's thought that the other cells, those cells that serve as the telephone wires to the brain, are intact. So if you can just replace the cells that respond to light with something that generates electricity and sends signals to the brain, you can start to restore vision. We're studying a device called the Argus 2 retinal prosthesis system, my second site in California. I think there are 2 or 3 companies in the world currently looking at prosthesis. There may be more that I don't know about. This one is what we call an epiretinal implant. It goes inside the eye and stimulates it. All these devices have external apparatus to them. They all have a camera which allows the world to be perceived. That camera image is then taken to some processing unit, they call it the VPU here, the video processing unit, which then turns the signal into something that you can use to stimulate the eye. Internal is a little more complicated. For the Argus 2, there is this device on your left that goes around the eye, and it's a relatively large device that serves as an antenna for signals coming from the outside, and as a processing unit to take the implant and take the information into the implant. So on the right, there's a sort of a schematic of what happens in the eye. The device wraps around the eye, as I said, and it's a small slit made in the eye, and that device is put in and attached to the top of the eye. And this is what it looks like. This is the first generation. So you can see it's rather crude. It's a very large device. Each one of the little silver dots there is the electrode. So what happens to the video signal is converted into, in this case, 16 little dots. And that's the amount of information you ideally get to the brain. And it looks, if you put a C on here and an array of 16 receptors below it, this is what ideally the brain would see to that C. And what you see depends on how many pixels of information you can get and get to the retina and have that transmitted to the brain. But it's a very crude representation of the visual world. And people liken this to phosphene. So if you close your eye and press on your eye, you'll see flashes of light. And it's sort of like that. None of this stuff is exactly the way it is described, but that's the idea. And the current device, as you see, is a little better. The holy grail of all this stuff is to get a lot of electrodes in the eye. The current device has 60 electrodes. You see the electrodes are a lot smaller, but they're spaced further apart. And again, the more electrodes you have, ideally, the better your resolution of the visual world will be. So there are some reports of the functional outcome. What can people do when you put this in their eye? And for the most part, you'll see this, and with the BrainPort device, they're very primitive sort of things. If you give someone a white square of about 5 centimeters to the side, and you put it on a black background, people who have this in their eye can reach out and tell you where it is. They're able to follow, if you put a line in a room that's relatively dark, a nice white line down the middle of the room, they can follow that line and walk with it. And there's some reports, although I don't know about these reports, where a few of the patients can read characters. So these characters may be about an inch in height, and they are able to read sentences, but their reading rate is so slow. So they're reading at 1 word per minute, where anyone with normal vision is reading 120, 160 words per minute. So you see, it's not really a reading device yet. What it is a device that gives you some visual information when you have it on. So the other thing we're talking about